Okay, so let's begin. Today we are going to discuss Grade 10 Mathematics, Quarter 1, Week 1, Lesson 1, CAPSLET by Ma'am Glissette C. Gallo, a former teacher of Zamboanga National High School West and is now my co-teacher at Talon-Talon National High School. So shout out po sa inyo, ma'am. Our topic for today is sequences. And our learning competency is the learner generates patterns with the following objectives. Number 1, describes patterns. Number 2, gives the next symbol or term. Number 3, find the next few terms given the nth term. By the way, nth term means formula. Number 4, find the next term. This is a correction kasi if this is next term, magiging parehas siya sa objective number 2. So, given a sequence, hahanapin natin yung formula, the nth term. Okay. Important. Do not write anything on this material. Write your answers on the learner's activity and assessment sheets provided separately. So you may write your answers on a separate sheet of paper. Okay, so let's proceed on our first activity. Do we have difference? Directions. Study the following set of numbers or objects or letters. Describe each. So you have here the following sets. We have 5 sets here. First set is, these are letters. Second set, this is a figure. Third set is polygons. Fourth set is also polygons. And fifth set, these are numbers. So the guide questions you have on the right side, you are going to answer those questions on a separate sheet of paper. Okay, so let's move down. Definition of a pattern. A pattern constitutes a set of numbers or objects in which all members are related with each other by a specific rule. Pattern is also known as sequence. So just like on your activity, the following sets are patterns because by definition, it is a set of numbers or objects. So just like this one. What is a sequence? A sequence is a succession of numbers in a specific order. So just like on your item number 5 on your activity, these are set of numbers. So a succession of numbers in a specific order is called a sequence. Each number in a sequence is called term. The terms are formed according to some fixed rule or property. They are arranged as the first term, second term, third term, and so on. So just like on our example, number 1 is our first term. Number 3 is our second term. Number 5 is our third. 7, 4, 9 is fifth. 11, 6, 13 is the seventh term. And then we have this ellipsis, 3 dots. So here is the definition of ellipsis. The symbol of 3 dots means and so on or continue on like manner. Now, let's have some illustrative examples. We have number 1, the sequence 3, 6, 9, 12, 15, and an unknown term. It says that on this sequence, the pattern is add 3 to the previous term to get the next term. So starting on the first term, 3, add 3, then we have 6. To get the next term, add again 3, 9, and then add again 3, we will have 12, then add 3, 15. Therefore, to get the next term, this unknown term, simply add 15 by 3. And you have your sixth term is 18. For the second illustrative example, we have the sequence 3, 4, 7, 8, 11, and then 2 unknown terms. It says that the pattern alternatingly add 1 and 3 to the previous term to get the next term. So add 1 and 3. Starting on our first term, add 1, we will have 4. And then add 3. 4 plus 3, we have 7. And then again, add 1, we will have 8. And then plus 3, we will have 11. Then plus 1, we will have, the sixth term is 12. And can you guess what is our seventh term? Seventh term is 15. Next, on our third illustrative example, we have the sequence 1, 2, 4, 8, 16, and then 3 unknown terms. It says that the pattern here, multiply the previous term by 2 to get the next term. So if we start on our first term, 1, multiply by 2 times 2, we will have 2. And then to get the next term, multiply by 2, we will have 4. To get the next term, multiply by 2, we'll have 8. And then multiply again by 2, 16. Now to get our sixth term, 16 multiplied 2, we will have 32. Now to get the seventh term, simply again multiply by 32, and then whatever the answer here, multiply again by 2 to get the eighth term. Now let's proceed on the two types of sequence. We have the finite and infinite sequence. A sequence with a definite number of terms is a finite sequence, while a sequence with no definite number of terms is an infinite sequence. So in other words, yung finite sequence, mabibilang mo lang or meron siyang last term. But for the infinite sequence, it's infinite, never ending. For example of finite sequence, we have here 5, 10, 15, 20, 25. So we only have 5 terms. So hanggang 5 lang, meron tayong last term which is 25. We also have 1, negative 3, 9, negative 27, and then 81. So we have the first term 1, the last term is 81. All in all, they are 5 terms. Now let's take a look on infinite sequence. We have negative 9, negative 12, 5, 12, 9, and then we have these ellipses. So if you already know what is the rule on this sequence or the pattern, you may continue to write the next term. On our second example, we have an ellipsis. So in other words, going left, we can write infinite number of terms following a certain rule or pattern from this given sequence. Now let's proceed on converting n term or explicit formula to sequence and vice versa. An explicit formula designates the n term of the sequence as an expression of n, where n is equal to terms location. We have here the steps in finding the terms of a sequence. Number 1, we have substitute the value of n in the given formula. Number 2, evaluate using PEMDAS. Now let's try this example. Find the first 5 terms of the sequence given the formula a sub n equal to 2 times the quantity of n plus 1. We have the table. Okay, step number 1, we have to substitute the value of n in a given formula. In solving for a sub 1, we have substitute n equal to 1. So this came from the formula a sub n. Remember, change n to 1 That's why we have a sub 1. And then by changing the value of n into 1, so you also have to change this n inside the parentheses into 1. Now you have this equation. A sub 1 is equal to 2 times 1 plus 1. And then step 2, evaluate using PEMDAS. So we will begin whatever inside the parentheses. So 1 plus 1 is 2. Then multiply 2 times 2, we will have 4. Now we have a sub 1 equal to 4. This means it is our first term. Next, let's try to solve for our fourth term, or a sub 4, by substituting the variable n into 4. So we have now a sub 4 equal to 2 times the quantity of 4 plus 1. Following the PEMDAS, we have 4 plus 1, which is 5. Multiply 2 times 5, we will have 10. Therefore, our fourth term is equal to 10. Remember, we need to generate the first 5 terms. We already have the first and the fourth. Now, we are going to do the same procedure. You try it on your scratch paper, following the same steps. Substitute n into 2, 3, and 5. And then you are going to list down all the sequence. Now, after you do that, you would come up with 4, 6, 8, 10, and 12. These are now the first 5 terms of the given formula. Next is we are going to formulate the explicit formula of a sequence. So, the other way around. Given a pattern, we are going to formulate the explicit formula. So we have step number 1, look for a pattern among the terms. And then for number 2, if the terms are fractions, look for a separate pattern among numerators and denominators. Number 3, look for a pattern among the signs of the terms. So aside from among the terms, we look also for pattern among the signs. And then number 4, write a formula for a sub n, or the n term, in terms of n. Test your formula for n equal to 1, n equal to 2, and n equal to 3 to know if your formula is correct. Now let's have an example. We will discover the explicit formula of the following sequence by looking at the pattern. We have 1 over 2, 2 over 3, 3 over 4, 4 over 5, and 5 over 6, and then we have the ellipsis. So for step number 1, look for a pattern. So given the sequence, since the terms are fraction, look for a separate pattern among numerators and denominators. So in other words, we are going to focus on the numerator and denominator, so separately. Now you can observe that our denominators here is greater than 1 compared to our numerators. It says here that notice on each term of the denominator is 1 more than the numerator. Okay. If you notice this, by writing down the first term, a sub 1, 1 over 2, second term, a sub 2 equal to 2 over 3, and then the third term, 3 over 4. Knowing that the denominator is 1 more than the numerator, we can write this fraction as 1 over 1 plus 1, because the denominator is 1 more than the numerator. The same for second term, 2 over 3, we can write is 2, and then on the denominator, more than 1, the numerator. And then for the third term, we have 3, and then on the denominator, 3 plus 1. Okay, so now that we already noticed the pattern, we can now write a formula. Hence, our formula is a sub n equal to n over n plus 1. This formula describes the pattern where each term of the denominator, so this is the denominator, n plus 1, is 1 more than the numerator. So if your numerator is n, your denominator is n plus 1. It's 1 more than the numerator. Number 2, we have negative 1, positive 1, negative 1, positive 1, negative 1, and so on. So for step number 1, look for a pattern. You notice that the number is constant, only the sign is changing alternately from the first term, negative 1, second term is positive 1, then negative, positive, negative, and so on. Now that we already observed the pattern, we are going to write each term in exponential form. The technique here for alternating signs is to write each term in exponential form. So for example, we have our first term, negative 1. If we are going to write this in exponential form, we have negative 1 raised to 1. And if we are going to simplify this, negative 1, in parentheses, removing the parentheses, we have negative 1. So that's equivalent to our first term. Now for our second term, we have positive 1. In exponential form, we can write negative 1 raised to 2 because this means we are going to square negative 1. We have negative 1 times negative 1. We have positive. So positive 1, removing the parentheses, we will have 1, which is equivalent to our second term. Next, we have a sub 3 equal to negative 1. We are going to write this in exponential form. We have negative 1 raised to 3. The equivalent still negative 1 because negative 1 raised to 3 means we are going to multiply negative 1 to itself 3 times. So following the rule, negative 1 times negative 1, we will have positive 1. And then this negative 1 will be multiplied to the positive 1. So the rule for unlike signs in multiplication, you will always have a negative result. Negative 1. Removing the parentheses, this gives us negative 1. So that's equivalent again for the third term. This time, we are going to write a formula based from the pattern that we observed, where on each position of the terms is equal to its exponent. So therefore, the explicit formula of the given sequence is a sub n is equal to negative 1 raised to n. Moving on, we have SAQ1. What is the importance of knowing the steps in formulating an explicit formula? Number 2, state or illustrate a real-life application of pattern or sequence. You may write your answers on your answer sheet. This time, we are going to apply what we have learned on the following activities. You are going to write your answer on a separate sheet. For the activity 1, what's my pattern? The direction is state the pattern of the following set. So we have 5 sets: phase expression, arrows, polygons, triangles, and numbers. You are going to write your answer stating the pattern of each set on the right side. Next, for your activity 2, what comes next? Direction, look at the pattern, write the next 3 terms of the sequence. So you have again 5 items. Number 1, this is a number sequence. Number 2, letter sequence. Number sequence for number 3, Number 4 is a combination of number and a letter sequence. Number 5, this is a number sequence. So you are going to look for the pattern and write the next 3 terms. Activity number 3, convert me. Directions, convert the following as indicated. Letter A, we have generate the first 5 terms of the sequence from the given formula. Before I'm going to end this video, I'm going to give an example on how to generate first 5 terms of the sequence from a given formula. So I'm going to provide an exponential one and a fraction one. Letter B, formulate an explicit formula for the given sequences. So you have 3 items. Okay, we are now ending this discussion. We have the following key points: the definition of a pattern, sequence, terms, finite sequence, infinite sequences, the steps in finding the next terms of a given n term, and then we have the steps in formulating n term or the explicit formula of a sequence. And then last is you are going to have an assessment. So again, you are going to write this on a separate sheet of paper. You have assessment 1, 2, and 3. Okay, so that's it. Okay, so this time we are going to generate the first 5 terms of the sequence a sub n equal to n squared minus 5n plus 2. To begin with the first term, we will assign n equal to 1, meaning we are going to substitute all the values of n by 1. Therefore, we have a sub 1 equal to 1 squared minus 5 times 1 plus 2. Then, by simplifying further, we have 1 squared equal to 1, since 1 squared is equal to 1 times 1 equal to 1. Then we have minus 5 times 1, that is 5 plus 2. Next, simplify further. 1 minus 5, we have negative 4. Negative because 5 is greater than 1. And then subtract 1 from 5, we have 4. Then bring down 2. Simplify further. Negative 4 plus 2, we have negative, since 4 is greater than 2. Then subtract 2 from 4, we have 2. Therefore, our first term, or a sub 1, is equal to negative 2. Next is solving for the second term. We will assign n equal to 2, then substitute all the values of n by 2. Therefore, we have a sub 2 is equals to 2 squared minus 5 times 2 plus 2. Simplify further, we have 2 squared is equal to 4 because 2 squared is 2 times 2 and that is 4. Minus 5 times 2, 10 plus 2. Then simplify. 4 minus 10 is negative 6 plus 2. Negative 6 plus 2, that is negative 4. Our second term, a sub 2, is equal to negative 4. Next, for our third term, we will assign n equal to 3. Substitute all the values of n by 3. Therefore, we have 3 squared minus 5 times 3 plus 2. Simplify. 3 squared is equal to 9. Since 3 squared is equals to 3 times 3 equal to 9. Then minus 5 times 3, which is 15. Then plus 2. Simplify. 9 minus 15 is equal to negative 6. Since 15 is greater than 9, we have negative. Then subtract 9 from 15, 6. Then plus 2, negative 6 plus 2, we have negative 4. Therefore, our third term is negative 4. Now we have our fourth term. We let n equal to 4. Then substitute all the values of n by 4. Therefore, we have 4 squared minus 5 times 4 plus 2. Simplify. 4 squared is 16. Since 4 squared is equal to 4 times 4 equals 16. Then minus 5 times 4, that is 20 plus 2. Simplify. 16 minus 20, negative 4 plus 2. Negative 4 plus 2 is negative 2. Therefore, our fourth term, or a sub 4, is equal to negative 2. For the fifth term, we will assign n equal to 5. Therefore, substitute all the values of n by 5. We have 5 squared minus 5 times 5 plus 2. Simplify. 5 squared is equal to 25. Since 5 squared is equals to 5 times 5, that is 25. Minus 5 times 5, 25 plus 2. Simplify. Since 25 minus 25 is equal to 0 plus 2, our fifth term is 2. Therefore, the first 5 terms of the sequence a sub n is equal to n squared minus 5n plus 2 are the following: negative 2, negative 4, negative 4, negative 2, and positive 2. Number 2, we have a sub n equal to 1 over 2 times n minus 1 over 4. As you can see, this involves a fraction on our n term. In solving the first term, or a sub 1, we are going to let n equal to 1. By substituting all the values of n by 1, we will have a sub 1 equal to 1 over 2 times 1 minus 1 over 4. Then, we are going to multiply this whole number 1 to the numerator. That is equal to 1. And then, we are going to copy the rest. Next is we are going to find the LCD of these two fractions since they are not the same. For 2 and 4, the LCD is 4. Next is we are going to divide the LCD by the first denominator and then multiply to its numerator. So 4 divided by 2, we have 2, and then multiply to 1, we have 2. Next, copy the same sign, minus, and then we are going to do the same process on the right side. 4 divided by 4, we have 1. And then multiply to the numerator 1. 1 times 1, we have 1. So therefore, we have 2 minus 1. Next is we are going to subtract 2 minus 1, that is 1. Copy the denominator 4. Therefore, our first term, or a sub 1, is equal to 1 over 4. So, for our second term, we are going to assign n equal to 2. Then, substitute all the values of n by 2. We will have a sub 2 equal to 1 over 2 times 2 minus 1 over 4. We are going to simplify this fraction by multiplying 2 times 1. We will have 2. And then the denominator, just copy, as well as 1 over 4. Next is, we are going to find for the LCD of 2 and 4, that is 4. Then, we repeat the same process just like a while ago. Divide the LCD by the first denominator. 4 divided by 2, we have 2. And then multiply 2, we have 4. So therefore, we have 4. Minus the same process. we are going to do 4 divided by 4 is 1 times 1, we have 1. Now we have 4 minus 1, which is 3 over 4. Therefore, our second term is 3 over 4. Moving on with our third term, we let n equal to 3. Substitute all the variables n to 3. We have a sub 3 equal to 1 over 2 times 3 minus 1 over 4. Then we simplify this mixed fraction. 3 times 1, we have 3. Then copy the denominator 2 minus 1 over 4. Next, find the LCD, which is 4. And then we do the same process. 4 divided by 2, we have 2 times 3, we have 6. Minus the same process. 4 divided by 4 is 1 times 1, we have 1. Now we have 6 minus 1, which is 5 over 4. Therefore, our third term is 5 over 4. Moving on with our fourth term. Let n equal to 4. Substitute all the variables n to 4. We will have a sub 4 equal to 1/2 times 4 minus 1 over 4. And then we are going to multiply 4 to the numerator 1. We will have 4. And then just copy the denominator 2 minus 1 over 4. And then find the LCD of 2 and 4, which is 4. And then do the process. 4 divided by 2 is 2 times 4, we have 8. And then minus, do the same process on the right side. 4 divided by 4 is 1 times 1 is 1. So therefore we have 1. 8 minus 1 is 7 over 4. Therefore our fourth term is 7 over 4. Okay, for the fifth term, we assign n equal to 5. Substitute all the values of n to 5. We have a sub 5 equal to 1 over 2 times 5 minus 1 over 4. Then we multiply 5 times 1. That will give us 5. Copy the denominator 2 minus 1 over 4. And then get the LCD of 2 and 4, which is 4. And then do the process. 4 divided by 2, we have 2 times 5, we have 10. Then minus 4 divided by 4 is 1 times 1, we have 1. Now we have 10 minus 1, that is equal to 9 over 4. Our fifth term is 9 over 4. Therefore, the first 5 terms of a sub n equals to 1/2 times n minus 1 over 4 are 1/4, 3 over 4, 5 over 4, 7 over 4, and 9 over 4. So that's the end of our discussion for today's topic. And if you have any questions regarding the topic, you may contact your subject teachers. We really hope that you have learned something from us. If you have any questions for us or suggestions to improve our video, please don't hesitate to say it on the comment section. We will really appreciate it. And if you find this video useful, please click the subscribe button and hit the notification bell so you would be updated for our next video. Have a great day and stay safe.